open source Linux Foundation project called OpenSDS, and which is going to be transformed into SODA Foundation. That's why you will see this SODA Foundation on the slides and everywhere. So this is going to be another data management, something like CNCF for compute. It will be the SODA Foundation will be for the data management. So that is what. And today we are going to talk about, like we have been discussing, right? Even in the previous talk, we were having this term multi-cloud, right? So the multi-cloud, we'll be talking about the securing, how the data can be secured in, and how we are doing, the OpenSDS is doing the multi-cloud data security, right? And data, as you know, like data, there is a data deluge, and everyone is like working around the data, either doing some analysis on the data, or some securing the data, or moving the data, migration and management, everything is around the data. We are playing around the data. So security comes one of the important feature. And here is what the agenda is. We'll briefly talk about what multi-cloud is, then how data protection in multi-cloud, what exactly is the data protection in multi-cloud, and then how we are achieving this security in multi-cloud environment through OpenSDS. And we'll talk about like OpenSDS, what exactly OpenSDS does, and what is the need for that. In between, we'll be going through that. And then we'll talk about some of the use case why we wanted this multi-cloud data security and all. So some of the use case we'll talk about, we'll discuss about, we'll get some inputs, we'll give some inputs. So that is how we'll discuss over here. Now multi-cloud, I think most of you might be knowing like what exactly is the multi-cloud, why we are having a need for the multi-cloud. So basically something like we have multiple vendors like AWS, Azure, GCP, OVS, and IBM. So everyone is playing around, like they have their own clouds. Now consider it as like a end user or someone who is going to use the cloud. Right? There may be some restrictions, there may be some requirements which may force them, or which may bring in the need for getting into the multi-cloud. So someone using AWS, because of some region constraints and all, they might have to use the Azure cloud, or they might have to use some other cloud like GCP and all. Or maybe based upon the cost optimization and all, they may need the multi-cloud thing, right? So suppose my compute on a certain cloud is taking more, is costing more, then I may move my compute to some other cloud. My data, whatever the storage is, there can be different storage types, right? The standard, if you know the standard, something like cold storage, hot storage. So there can be different costs around that. So that requires the multi-cloud use cases over there, right? So this is how so this is just the definition, but to talk about, that is what the multi-cloud is, right? Now OpenSDS, okay. So OpenSDS is is the open source data management platform. Right? So when we say the data management platform, it can be like across the cloud, on the premise, or in a hybrid cloud, or even your like legacy storage and all, right? So I have some computes like a VMware environment from where I have been provisioning the storage from storage array, say a NetApp or EMC and all. So whole data management, the like provisioning and all, that can be achieved through OpenSDS. Now you will say that, okay, that can be like, okay, NetApp or EMC might have been giving, or even AWS or Azure may be providing that facility for data provisioning, data management and all. But think of it as like end user who is having multiple environment. There can be like some companies or some, they may have multi-vendor shops, right? Someone using the AWS, Azure, or NetApp, EMC, HP, IBM, all, right? Now they will need some common solution which will give them an ease of data management. So that's why, one of the component of this OpenSDS is a multi-cloud, which we call it as a Gelato. Gelato, all you know, right? Yummy thing.
How many
right?
of you know Gelato?
Yeah, you must have, like, if you have sweet tooth, you have some experience. Okay.
So all the other components of OpenSDS are like that, some dishes names. So Gelato for multi-cloud and Shusri for NVP, northbound plugins, and Hotpot for OpenSDS controller.
So this is what, like, OpenSDS project is Gelato. You can go and search in the, like, we have a GitHub repo, OpenSDS repo. You can go through that. Now, why we wanted this Gelato or the multi-cloud solution in OpenSDS? So consider it like there can be multiple use cases, right? User may want to, so I have some analysis needs to be done, like, then I can move my data into some of the cloud, do some analysis, like spawn a compute, do some analysis over there, get back the result, and remove the compute. So that data from the on-premise, we can, so as I said, it is a multi-cloud which includes the on-premise, public, private, hybrid, all clouds, right? So from on-premise, I have a safe cloud. I can move it to the AWS, do some computes, get back the result, come back and do the rest of the things on the on-premise, right? Or the private cloud. Now, user can have a requirement of, say, for example, I have some logs, right? Now, these logs I have been using right now, but it may get cold, right? I don't need those logs, but for some purpose, I want to keep it, right? So, say, for example, in AWS, I have used a standard IA, right? Standard or standard IA storage. So you might be knowing about that standard. So this is like a very hot storage, you can say. And now, as I know that hot storage will cost me more, I'll move it to Glacier eventually, or the cold storage, right? Because I don't need to have the logs in front of me every time, right? So we can have some lifecycle management, data lifecycle rules that can be put over there, where I can say that after 30 days, move this log data or the folder into the Glacier storage. Glacier is the cold storage, right? That will cost me more, which is nothing but, like, you can say it as a backup storage, right? So those lifecycle management and Gelato or the multi-cloud provides it not only for the cloud, but across the cloud. So I can say that, okay, on the AWS hot date, whatever the storage is, you can move it to the Azure cold storage. So those lifecycle rules can be provided. That is how. Now, there are like frequently accessed data, we can have the lifecycle management and all, and even the data migration. Say, for example, I am going to use my data in some other region where, say, for example, the AWS cloud cannot be, the computes cannot be available, but Azure can be available. So my data in the AWS cloud can be moved to the Azure data in other regions, right? So those data migration facilities we provide. Now, when we are playing with this data, the data security comes in picture, like every month for the compliance, for the whatever the governance and all, we need the security. So data, if we see few years back, everyone when they were going to move to cloud, the security was one of the main concern. Right? So how my data is going to be secured? Then cloud providers started providing the security features, the data at rest, data in flight and all, right? You can use the KMS and all to secure your data. Now, if you see, AWS provides this, Azure provides this, GCP provides this, all they provide the encryption and all. Now, how my data can be protected, and say for an end user, say a company, say some telecom provider or a service provider, which wants to cater to different companies having different storages, right? Different cloud vendors using their cloud, right? Now I want to secure their data, which can be done through OpenSDS. OpenSDS, you can consider it as a sitting above all these clouds for the management. So AWS, Azure, GCP and all, and this can be a management layer which can manage all the data over there. Now, how we achieve the security in multi-cloud is something like multi-tenancy. We'll go through this, how we manage the multi-tenancy. AKSK, everyone, access key, secret key, everyone knows. Whoever is using cloud, they know about the AKSK, right? Now, AKSK, how OpenSDS gives a wrapper around AKSK, we'll talk about that. Because there can be different AKSK for different cloud providers, for different users. So how the multi-tenancy comes and how we are solving, we'll talk about that. Himanshu will talk about that. Then data in flight, we talked about that, HTTPS, TLS and all, right? So data in flight, we are using that HTTPS, so that is secure. Now comes the data at rest. So when we are talking about this data at rest, server-side encryption that we use. Now, how OpenSDS does is that whenever you are moving the data from across the clouds, we use the native cloud encryption mechanism to provide the data security. Right? So for example, if I am putting my my object in a Azure container or a AWS bucket, it can be secured using the KMS or the customer key or the server-side key that can be secured. That is something we are leveraging the cloud providers encryption mechanism, but we give to the end user, it is something like very transparent. Right? They don't need to care about like which mechanism it is using. They can use OpenSDS as the gateway through which they can provide get the secure data management. Okay, so Himanshu will take you through the AKSK.
Yeah. So rather we call it like AKSK management. It's identity management for multi-cloud, which provides which supports like user authentication. So we mainly provide like identity verification for the requester and in cloud data protection. So identity management, what I mean by that, like the request will be identified using the access key, which is a combination of access key ID and the signing key. And in cloud data protection, we basically generate some signature out of the request and embed within the request as a signature. Once the service, the multi-cloud service gets the request, it uses the same information to generate the same signature and calculates the signature again and validate whether the signature, whatever is passed with the request and the generated one are matched or not. Based upon that, the request will be granted or will be denied. So these are the steps for authenticating the request for multi-cloud API. So basically, user send request to the keystone to get the access key and generates the secret key, which is being stored as a credential object. As you know, like Keystone provide some of the APIs for storing access key and secret key for cloud blobs as a credential, and application credentials are also being stored in Keystone. Once those are stored and the request has come, the secret key, using the same information, user receive the token, and using the token and the secret key, it basically signs the request, generating some signature based on some algorithm. So we use some algorithms related to SIGV4 like AWS support. Similarly, we have some algorithm in OpenSDS to generate the signature. Once the request is signed with the signature, then the API will be hit by the same request. The API handler again access the keystone with the access key, where whatever is identified and embedded in the request generates the signature again and calculates the signature, then validates whether the request is having the same signature, whatever the identity is maintained by the user. Then based upon that, the request will be accepted or discarded. So yeah, some of the use cases, Ashit can cover.
Yeah, so when we are talking about this AKSK, also talking about the AKSK. Now, one of the things is that OpenSDS has got a big community. Now, these use cases, why we wanted to do it like this and what is the requirement, that use case is coming from the community where different companies and partners are there. So one of the use case was, say for example, you have one bucket, right? Now, that bucket is something like provided by the service provider. Now multiple users comes, right? One user is, say, I'm one of the user, he is one of the user, right? There is a single bucket, consider it like this. There is a single bucket. Now whatever objects I am putting, that should not be visible or accessible to him, right? So that is something like where AKSK, when he was telling about AKSK and we talked about that, it is a wrapper over the native cloud AKSK, right? So for each of the user, even though there is one AKSK, say for example, let's take an example for the AWS, there is one AKSK. Now for different users of OpenSDS, we'll be generating different AKSK. Now internally, that will be routed through this AKSK. But for this user, when he is accessing the objects, it will be just for whatever the AKSK, through the AKSK he has put. That is one of the use cases. So
in this way, right, we separate the user space within the same bucket in the cloud.
So you can consider it like a directory and subdirectories we are creating. That is what the subdirectories access level, the access control can be managed at the subdirectory level. But the directory level, it will be a common admin access, you can say. Right? So this is one of the use case that object user 1 and object 1, user 2 and object 2, admin has provided the AKSK. Now the user 1 can see whatever objects it has put in the same bucket. If you see, there is just one bucket B1. So it is accessible only for the user 1, O1, and O2 is accessible for U2. So that is one of the use case. Now other use case, there can be different use cases. One of the use case that was proposed by someone in the community. So it was something like, for example, I have a file, right, that I consider it as a master file. Right? Now this master file, I have given access to different people, but I want to keep a master file always. Right? Now this master file cannot be accessed by other users. They can have their own versions that can be created. Now when we talk about the version, everyone knows, like you might be knowing, the cloud providers gives the versioning, right? Azure gives the snapshots and all, AWS provides the object versioning, right? So you can have multiple versions of the same object. Now this user can have their own versions, but they cannot have an access to the master version. So for example, let's take an example of 1.jpg, right? 1.jpg will be accessible to the admin. Now someone copies it, downloads it, does some modification, they can have 1.jpg, they can upload into the bucket where the versioning is enabled. It will be something like 1_1.jpg. Another can have 1_2.jpg, right? But 1.jpg is only with the admin. So that is something how the data can be secured. So we, along with the encryption and all, we provide the versioning also. We support the versioning also through OpenSDS for the different cloud providers. And same, consider it like when we are saying that encryption. So for example, user 1 and user 2, the example that we were taking, right? User 1 can have their, for the same object, user 1 can have their own key, user 2 can have their own key. Now the keys are not shared, but they can access this object, they can encrypt and decrypt through their own key. The user 2 can encrypt and decrypt through their own key. So that is how we, the multi-tenant, and in a multi-tenant environment, they can have their own keys, the keys are not shared. So that's how we secure the access of the objects through different users.
Data encryption.
Yeah, data encryption. Okay, so as we said, we are open source. So anyone can join. You can go to this opensds.io. We'll soon be like, we will get some information about the SODA Foundation and all. And then we have this GitHub repository. You can go fork star and see what we are doing for the different northbound plugins, southbound plugins, and the multi-cloud environment. We have telemetry solutions. We have some big data analysis solutions. So these all services are coming into. And again, the Twitter and the Slack channel, you can join us and provide us feedbacks, help us. That is how. Thank you.